Okay, hello everyone. Welcome to another Wolfram language design review, part of our incremental language design, language development series. And we have a variety of topics. The first one here is Georaster. So let's take a look. How do I run Georaster? Do I have to load in a package?
Oh, yeah, you probably need to do needs, Christopher Wolfram backtick Georaster. So for context, I mean, this is like a very prototype thing that I made in the last few days at the summer school. And there's lots that's broken about it, but it was sort of there's some design ideas in it.
Okay. It's a good launch point for discussion.
Yes.
Okay, so the basic idea is supposed to be that this is representing a bunch of essentially pixel values, geopixel values in some sense. Is that right? So the values could represent, population density, or they could represent all kinds of things, or they could be a picture. Is that right or not?
Yeah, basically. Technically it's a georeferenced image. So it's an image where it knows where it is on the Earth. I think in terms of like how we actually think it, the data is represented, the way they usually do it in remote sensing is they'll sort of say that, you sort of imagine that each pixel represents a square region, and there's a value that's constant within that square region, and so on. So I mean, that's basically what this represents.
Mm-hmm.
And just also, right. So I mean, the other thing is that, the way that these have been set up is, each raster, it's a single, image with an arbitrary number of bands. It also has an alpha channel and it has units. But there's no, we don't allow things like, different units for different bands or stuff like that. For that, you need to have multiple rasters.
Okay. And is that, I mean, okay, so if you wanted population density, you want to divide, vegetation density by population density or something, you would take two different rasters in different units, divide them, and get out a third raster in the combined units. Is that kind of the idea?
Yeah, basically, ideally, yes. I actually almost had that exact example, except the website where you download a lot of those, geotiffs was broken earlier today, so I didn't get them, but yes.
Okay, so the concept is, so you're suggesting that image processing operations could work on these georasters, is that right?
Well, so this is one of the main questions. I think there are two, I mean, in making this prototype, there were two main sort of things that came up repeatedly that sort of required, some consistent decision. So one of them was, to what extent georasters should inherit image processing functions, and to what extent they should have their own functions. So for example, I think it's useful for something like binarize to work on a georaster. Though there are probably some changes to how the normal binarize works, like the fact that if we have georasters that can have units associated with them, you'd like the threshold parameter to be so it could be a quantity, which is a little bit different from normal raster binarize. But then there are other operations like, I would probably argue something like pixel value or like image value. We should not have a version of image value that takes a geoposition, right? Like that would be, I think that's stretching the image analogy too much. So I mean, sort of I think there are different, places we could split it. The sort of general principle I used here was, on the handful of operations I implemented, basically, if the function needs to know about sort of the projections or geopositions or just the spherical geometry of the Earth, or spheroidal geometry of the Earth, then it should have its own geo function. And if it's just a blind thing, it's just applying to pixels like binarize, then it should just work with the image processing function.
All right, well, let's take a look at some more stuff here. So
before we move on, I think the key question in my mind here is the relation between georaster and geoimage. So for geographics, what we did is that geographics has in the first argument a graphics object. But for geoimage, for some reason, we didn't go that route. So geoimage could have been an object that contains an image in the first argument and then contains options, geo options additionally. So I think this is something like recreating that scenario. Georaster of geoimage, because geoimage returns an image, plays the role of geographics around graphics.
But then as far as options that get stored in the returning image object, there is no additional options that you support in geoimage. Well, the result I'm asking is just an image, not a geoimage object.
Right. That's why Georaster would add the geo options, like geographics adds the geo options to graphics.
Yes.
Yeah, that makes some sense.
So my first question for Georaster is that what are the options or additional arguments that Georaster has that currently image does not have?
Right. So there's two things. So the first thing is, I mean, in terms of options, it's basically the geo options. So the important ones for this are what is it? Geo projection and basically plot range. But now the differences from images. So I mean, the first thing is, I think there's a couple of things that are a little different from images, like for example, supporting units. Although I guess we could maybe have images with units on them. But the other thing is that there are some cases where I think the semantics have to be different for georasters versus images. For example, if you have two georasters that say have the same dimensions, but they're in different projections, or they represent different areas on the Earth. If you try and multiply those together, I think that shouldn't work, or at least it should either fail or it should do reprojection. It shouldn't just blindly multiply things that don't line up. But of course, if they were just had head image, it would have to do that.
Right. In fact, we have this very same problem in show of two geographics. Rather than overlaying one on the other, it recomputes a region of the world that contains both geographics.
Okay.
Right. So that was one of the other. Yeah, sorry, go ahead.
The plot range problem, which is part of what you're describing here as well, has come up when we have come up with I think it's called region image function, when we are going from a region that could have a different plot range than the typical either 0, 1, 0, 1 or 0 width, 0 height, and we completely lose it as we convert it to an image, because image does not have this plot range option in it. So that request has come up there as well, and in many other places, like where we would like to have, say, a microscopy image has a sense about what was the length unit of each pixel, so that we want to know the whole image is so many nanometers times so many nanometers, and then the measurements can come back in that length measure units. So I think in general, adding plot range to an image object has been requested from different domains, and it's something that is of interest to the image object in general. Geoprojection, I think, is completely specific and useful only in this discussion of georasters, geoimages. Units as well, however, I can see being of interest for other applications. So I don't think that as well is very unique to geo.
Okay, but so let's summarize this. So we've also got spherical image coming, which will have its own projection issues.
Correct.
But just like an array plot, you can give a data range that tells you, what are the absolute coordinates that this matrix should be placed at. It seems to me that that's not an unreasonable kind of approach to take with image, is to have some kind of data range or something kind of option that specifies, how should this be placed in some absolute coordinate system.
Right, which is similar to how plot range works in geo functions. Right. Actually, I wasn't aware.
I thought it's geo range. It's geo range, right?
So geo range gives you the range where you give it sort of geographic, you'll give it like a geo position or a geo region, and it'll include that region. Plot range is in the coordinates of the projection. So if I say, the projection is Mercator, and maybe Mercator is 0, 1, 0, 1 for the whole Earth, then I'll, those are the coordinates.
Isn't that in GeoGrid coordinates then? So is that the GeoGrid coordinates?
Yes, there is in fact a GeoGrid range, which is essentially a synonym of plot range. So I think image should be compared to graphics, not to geographics, because graphics already has a plot range, which image does not.
Yes, but another comment about this. I can imagine another thing we might want is something where the raw georaster has values of, I don't know, vegetation levels or something, but that for the display of this thing, we want to use some particular color map, which I guess we just have. It's just to be a color function of some kind.
Again, image object doesn't have a color function, but it has come up enough that I think, yes, we should add it as an option to image so that one can specify how to color.
Right. I think we even talked about, last time we talked about this, like, a million years ago, one of the things we talked about was, sort of handling of images where they maybe have an arbitrary number of bands, which is something that we kind of support, but there's a few places where it kind of breaks down a little bit. At least there are cases where, for example, it's ambiguous whether the nth band is the alpha channel or whether it's just you have an n band image. But I think one of the things we talked about was having, again, this is a while ago, but I think we talked about having some like color space or option where you would give it some sort of matrix, and that would sort of tell it how to linearly combine its n bands to produce an RGB image, if that makes sense.
Named colors, named channels had come up in that same discussion as well, and then making up a color function based on those named channels, I think, was discussed again.
Well, why on earth with named channels? Why isn't that an image data that's an association? I mean, as we build these associations, which are these column-oriented associations, that should work just fine. I mean, right now we might have to have something that says, desert level or something. For every single one of these, for every single pixel, we might need values,
Right. I also do think that for georasters, I would probably argue so when you get, if you have like a, what are they called? There's like netcdf files, there's geotiff, but some of them, like netcdf, they support many layers, and then they might be in different formats, they might be in different resolutions, they might they'll have different units and stuff like that. I experimented in an earlier version of this with having like many of those in one raster, and this was a bad idea because it just meant that each raster just had too much stuff in it. Where, for example, you couldn't talk about the resolution of the raster because it would have, different resolutions depending on which layer you're talking about. Yeah. So, I mean, I guess we probably could have named bands would still be useful for doing things like saying, this is the red green, this is the near infrared band, this is the, far infrared band, whatever. But I think it's probably still different from, the issue of I have population and I have vegetation index.
Well, okay, but it seems to me that in general, as soon as we have column-oriented, list association combos, column-oriented data set-like things, that will be a good data structure to use for named bands for image. Do you agree? Shadi, do you agree?
Except that I think each column or quote-unquote column is going to be a 2D array.
No, I
think the point is that image data,
yep.
right? Well, I think the thing is, the problem is the image data, gives something where the bands are at the lowest level, right? And right now, there's no good way of representing that without having a bajillion associations, which is horribly inefficient. But I think the point is there's been various things, like Rob Knapp has had stuff about basically being able to represent lists of associations like that where it's efficient. I mean,
right, which we're about to get. So I mean, we can assume that's coming. So there'll be an efficient way to represent something which is as if instead of an RGB list at the end, it's an association. And then we can have in the color function, we can have named, hash ocean level and things like that.
Mm-hmm.
In other words, the color function would by default would take, color function would be, well, we'd be able to say things like,
well, like hash near infrared or something.
Yeah, right. But this would be the usual thing with RGB or XYZ or whatever it is, but then or something with an alpha channel. That would be.
Although in the example you're
thing.
writing, it would return a grayscale. It would display in grayscale, presumably.
I suppose that's right, because otherwise you'd have to have a color function, which but this actually would be a wrong thing. I mean, this would be I like grayscale, gray level of this.
Yeah. Although I do worry a little bit about efficiency for
I know,
that, but yeah.
Well, that's a separate thing of being able to compile that, et cetera, in the future, blah, blah, blah. Even now, using the existing compiler would already be useful for this. But, or the name channels thing where this is, near IR, whatever it is, far IR, whatever, IR, UVA, whatever the heck it is. Okay.
I was gonna say you could have the color function return a list and have it then use the RGB if you return a triple type thing.
Mm-hmm.
Sure. Okay, but this is okay. Let's come back to the georaster. So what we're concluding is that image needs a little bit more annotation, and that one of the issues is given the data range of two images. If two images have two different data ranges, what thing do you have which is the stitching that, do you get what I'm saying? That stitching with the actual data range. How would you do that? Would show do that?
Maybe image compose or something?
Would pay attention to the data range.
Well, so there's a thing, actually, maybe, okay.
But a lot more as well. Everything like image add, image multiply, potentially image align. I think this can go anywhere.
Okay, so you're saying data range arrow automatic would just place it by pixels, and then it conforms, it does whatever it normally does to conform, but data range, a specific data range, would cause it to actually, take account of that in doing composition of images.
Mm-hmm. Which I think immediately implies that image should have some kind of a padding option as well. Whether we want anything.
Sorry. Well, so one issue, I had an earlier prototype of the Georaster stuff that basically did this, but a little more extreme because it would do reprojection. So if you, for example, if you see these two Georasters here in that conform Georaster example, you see, there they are conformed to be in the same projection, same plot range, same resolution and everything, right? So they pixel aligned. But in an earlier version I had, so it would automatically, if you multiplied those two together, it would automatically conform them and then do that and so on. And this led to all sorts of problems because, first of all, you don't even know if they're the same resolution, right? And so you don't even know, once you conform them to some common grid, basically, you don't even know what resolution to make that common grid, because maybe that small image, maybe the big image is way lower resolution in terms of pixels per unit of data range than the other one. And so you're either going to make some absolutely massive image, or you end up destroying a bunch of data, and it's really case by case which one you want to do, and very hard to predict, at least when I was experimenting with this. I mean, it's even worse in the geo case because, it's even worse in the geo case because you also have the projections running around and stuff like that. But yeah.
Right. Okay. So what is your recommendation here? Your recommendation is that by default.
So I listed this was the two core design questions I listed was 2.5. One was the thing about one was the thing about image functions, like should binarize work, should image value work. The other one was about this exact issue. So in an earlier prototype I had, like I mentioned, it just did everything automatically. If you multiplied two incompatible things, it would pick something and it would run with it and so on. It would pick some common projection and so on. In the more recent versions,
what does image do if it, for example, has incompatible color spaces or something?
Depends on the operation.
Well, I
specific
say that the
operation
analogous
you're
thing,
asking.
the thing that I started looking at was if the dimensions don't match, because I think that's kind of the same. It's basically if the pixels don't line up, right? I mean, the color spaces, you can often do things like, for example, multiplying a grayscale image by an RGB image. It's kind of obvious what to do. But if they're different dimensions, that's the analogous case where basically they spatially don't line up.
So what happens? What does it do?
Some functions fail. Some functions like image compose just put one in the center of the other one.
That's pretty random.
Right.
And if there was a data range, it wouldn't do that. Then it will be hinted to say what to do.
Sure.
Well, with image compose it's been a while since I've used image compose, but doesn't it have
image
like
compose, in fact,
doesn't
really require any conformed images.
Because you can place them anywhere, right? Like you can tell it to place it in some weird position. So it's kind of what it does. But like if you're multiplying two images, it complains if they have different dimensions.
Sure.
So I mean, so the second version of this, the version that I have in this notebook here, basically I have a function called conform georaster, which is a little bit like conform images, but it has some slightly different usages that basically is supposed to make it easy to get your rasters to pixel line up, so that you can kind of be responsible for that process instead of it trying to do it automatically. So the main usages were you can give it a list, and then it will try and quote unquote intelligently pick some common reference. Right. The other option though was I had it so if you give it, if you have two georasters, if you give it, if you just give it those as separate arguments, it'll conform the first georaster to be in the spatial reference, to match the spatial reference of the second, which I think is useful for, if nothing else, I mean, because I think the most common case is you'll have many different, different sources of raster data, and maybe they have different projections and different georeferences. And usually you'll want to pick one as sort of, this is the one that is like my core piece of data that I want to use. I want to convert everything to the reference frame of this data. Usually because maybe this one is the lowest resolution one. It's kind of the important bottleneck. And so I don't want to destroy it anymore by reprojecting it or something. So I think that just automatically picking something often inconsistently will probably lead to weird results. So it's better just to make it easy for people to pick a single projection.
Well, here, I mean, this conform images has kind of a size. The second argument can be either an image to conform to, or purely a size, or some other things.
Mm-hmm. Correct.
Right.
And I could imagine it being useful to conform something to a geoboundary or something, to a geobounding box. Does that make any sense?
Yes, and then that's basically what conform georaster does, but it also conforms, for example, the dimensions of the image, like the raster size.
Okay, fine.
And also the projection, but actually one other detail just to mention is, there's an in-between thing that this could easily do, which is instead of just matching the images to be the same dimensions, it could just match them to be the same projection and the same resolution. So that is the same number of pixels per unit of plot range or per unit of data range or whatever. Because then, as long as you can get so the grids line up, it's unambiguous how to combine them. And you don't have to, for example, do things like if you see this conformed image on the right, where it's got, tons of alpha channel wasting space. So yeah,
that's effectively what geographics does when two of them are combined in show. So the options are preserved, but the georange is the union of the georanges, and the projections and zooms are forgotten and recomputed.
Okay, so that's a yet different thing. That's a non-conforming thing That's just the default. That's show.
That is a conforming thing. I mean, that is basically, if you gave conform georaster a list of georasters, that's basically the procedure that it should follow. I mean, picking a common projection and everything. There's some complexity about what's the resolution, but again, you just need some heuristic for that.
Right.
So the images here, because they would have their own georange, would play the role of entities. It's like giving a bunch of polygons of countries, and geographics or geoimage or georaster would decide what's the best configuration.
Okay.
Mm.
All right. So let's look down at these design questions.
But one quick point about that is I think that in most real world usages, other than just simple visualization cases, you won't want it to do that, because you'll have weird problems where oh, I've got these 100 different images I'm going to be computing this on, and on some of them maybe it picks this one projection, and on others it picks this other projection, and because one of these is has a projection that distorts badly in this case, it's going to destroy a bunch of data, and you're going to get you're going to get kind of garbage results. So I worry. I mean, even if the heuristics are good about picking what common projection to use, I think that there's still be cases where you'll get inconsistent results by doing something like that.
So, okay, hold on. Actually, just hold on 1 second. I'll be right back. Just a second. I'm sorry. Yeah. Okay. So let's summarize what are the questions here. So there's a question of what to do if you are showing multiple georasters together. Is that right?
Well, it's not about showing them together. It's about if I want to multiply two georasters that are in different projections, different resolutions, etc.
Right. And you think that should, by default, just fail?
I think probably it should just fail, because I think that doing the reprojection is, you have to make choices that kind of matter.
So long as the failure basically points people to conform georasters, probably it should be plural, to be like conform images. That's probably okay, at least at the beginning.
Mm-hmm.
Now,
I mean, I guess we could always add, but we could always change it so that maybe we could add auto projection, but we can't get rid of it.
Yeah.
So before we proceed with all of the design questions, are we sure georaster is not going to be confusing with geoimage, maybe with image, with geographics and all of that? Especially with geoimage, I think they really sound to be exactly the same thing. Potentially, we can ask whether geoimage should return georaster or geoimage should return a geoimage with all the additional useful options. But I really think having them side by side might end up being confusing.
Well, look, now, geoimage returns an image.
Yes.
And changing that will probably break things, unfortunately. I mean, I think it's, I agree. I think it is very confusing. But it's sort of unfortunate because I don't really know. I predict it would break things if we started returning a different kind of object.
Well,
from geoimage.
Look, if geoimage returns a geoimage, so to speak, and image processing works on it, then probably nobody will even notice that it isn't an image.
Maybe, but for example, just maybe this is a weird case, but if people say get different geoimages, let's say I wrote a program that gets different geoimages of the same resolution, for lots of different areas, and it sort of, fades them on top of each other. That will fail with any kind of georastery thing, which should complain about such an operation. So I mean, I think the kind of lame excuse I was making for why georaster could be a separate thing, although I acknowledge this is a lame excuse and that it's still be very confusing, is that georaster could in some ways be similar to how raster is versus image, although arguably raster maybe shouldn't even exist anymore. But basically the argument being that, raster is like a graphics primitive, that you can put directly into graphics, and presumably georaster, one of the nice things you'd want to be able to do with it is to feed it into geographics and have it just show up as though it were sort of a graphics primitive. But obviously this kind of breaks down because you don't run binarize on a raster object. But yes.
Well, maybe you shouldn't be running binarize on a georaster either. I mean, maybe that has too many.
I think it would be pretty useful, but yeah.
Well, I mean, it could work as a courtesy, but generally, if you want to run image processing operations, turn it into an image. So how would you turn a georaster into a plain old image?
So I had a couple ways. I mean, one is, I had some accessor thing where you can just say of quotes image. But I think probably the better thing is, well, maybe the better thing is I had this thing, what is it called? Georaster data. That's kind of an analog of image data, but it does more stuff because it needs to. So for example, image data normally just gives you the pixel values, but the idea is georaster data would give you things like the pixel values, but it could also give you, for example, the areas of the different pixels, right? Because if you're not using equal area projection, each pixel might represent a different area, or it can give you the pixel values as a weighted data object where they're weighted by the areas, which is something that, there are a lot of remote sensing papers and software that does not do this, which is kind of crazy because they make histograms of pixel values over large areas where the pixel sizes are radically different in different parts of the raster. But right, so I mean, this sort of thing. But one of the ideas, georaster data, if it's returning all these different kinds of things, could also easily have an image property that it could give you.
Although I think just image of georaster should probably work. Or maybe it's geoimage of georaster.
Oh my God. So we'll have geoimage of georaster of geoimage.
Why would you put a geoimage inside the georaster? You'd have to tell the geoimage what part of the Earth it corresponds to and things.
Well, right. I mean, the reason you'd have the right. I mean, some of these examples, what I do is if you have so geoimage returns images, but it actually has metadata about where the image is. It has a spatial reference. And so one of the kind of bridging things I had, at least in this prototype, was if you give georaster one of these images that has a spatial reference, it will use it and turn it into a georaster. So you can actually run georaster of geoimage.
Right, but that's on the basis of this idea of basically adding to image some metadata.
Well, the point is the images produced by geoimage already have that metadata, but it's not used anywhere. I mean, it's just kind of in the meta information option. Right. It's like EXIF data.
The plan there was that we would be able to insert any of these images inside geographics and it would appear immediately. It can be done because there is enough information already there if you ask for meta information of this.
Can I just say meta information of that?
I think it's options,
no, options of
meta
measure.
information.
Yeah.
There you go. Geo meta information.
Wow.
I don't even think this is documented anywhere, but I could be wrong.
No, it's not, because it's not used yet anywhere. So you see how there is the proper geo information, the long lat box, and the plot range. The plot range could be moved to the image itself. It's what you were calling data range before. But the long lat box is purely geo.
Mm-hmm.
And the projection.
And the projection, exactly.
And
But the plot range
here.
depends on that and the projection. So
yeah. I just want to say, although I know that plot range is a long wanted addition to the image object, adding it to the object is easy, but properly working with it in all the 200 and something functions we have is going to be a huge project.
All right. Right.
Yeah, but I mean, that will get slowly done, hopefully.
Sure.
Okay, so
I mean, I guess it's a similar thing for something like units. I was even wondering, I mean, for units, when I was playing around with this, because there's behavior with units that's very unclear what it should do. Like I started by just saying, oh, I'm going to kind of, I didn't implement anything too serious, but I was like, I'm going to vaguely emulate quantity array. But then there's stuff like if you run log of a quantity array, right? Log of log meters is not a unit that I think we can really, handle right now. And so what, if you run log of a quantity, it just returns unevaluated log of quantity of blah. And so the quantity array, if you run log of a quantity array, turns into a list of log of quantity of blahs. But there's, of course, you can't do that behavior with an image. So I guess you'd maybe return an unevaluated log of image thing, or I don't know. There's all sorts of messiness there.
Okay, but I think it is clearly useful to have values in an image, or at least in a georaster, be united. So
Yeah.
really that.
Sorry, something related to that, and something that I miss frequently in images is that sometimes, for example, in elevation profiles, there is some sort of hole value. These elevations are typically given in between minus 32,000 and plus 32,000 in meters. And when there is a hole, they just assign value minus 32,000. But this is inconvenient when inserted in image because it rescale everything and then everything becomes black, for example, just because that value is there. So it would be great to have some sort of background value or something like that in image, such that that value is not used for visualization.
Right. There's actually two different. I had two different versions of those that I was playing around with Georaster. So one is exactly that, the fill values. You can at least get the behavior of fill values, although maybe not the efficiency of it, by having an alpha channel. So we can kind of do that semantics right now, but again, it's not as efficient. Although if a lot of georasters have alpha channels because they've been reprojected and they're no longer even rectangular or something like that, then it's kind of free to then maybe include holes in the alpha channel. The other one, though, and this is again just sort of an efficiency thing, is oftentimes you'll get one of these rasters and it'll say something like, okay, this is a, what do we call it, bit 16 image that's between 0 and 65, 65536 or whatever it is. But then you'll be told that, okay, this is in units of meters, and 0 corresponds with minus 1,000 meters, and 65,000 corresponds with 12,000 meters or something like that, and you're just expected to kind of linearly interpolate. And that's, right now, the only way we can deal with that is by just saying, okay, well, I'm not going to really represent the image as a bit 16. I'm going to rescale the whole image and represent it as some real 32 or something like that. But that can often sort of destroy data a bit. And it can sort of, and of course, it means that the image isn't, it's using twice the memory and stuff like that. So that's another similar kind of thing.
Why aren't we using this, data frame-ish type technology to be, you've got the raw image inside or the raw raster inside, and then all this stuff about providing units and this and that and the other. Why isn't that in this framing wrapper, which is kind of maybe more or less what Georaster is?
We do have planar images already support that, which means instead of having the RGB or channel 1, channel 2 vectors listed in the image raster, we can have all of channel 1, then all of channel 2, and so forth. And we do handle processing planar images as efficiently as in interleaved images. It's just that we don't name
option. Yeah.
Yes, the interleaving option. It's just that we haven't named those channels yet. Or haven't given those channels any unit or any specific description of any sort.
What do we need to do to move this forward? So we've got.
Well, are we talking about making all the upgrades to the image object or the georaster? Moving georaster forward?
I think moving georaster forward is the low-hanging fruit of functionality, but putting these additional things into image is a longer-term play, but one that we should at least understand when we're designing georaster.
Right. So maybe the thing to do, I mean, because I was going to say, it sounds like, if we want all the things we want in Georaster, probably, it probably wants to inherit a lot of that functionality from images. So maybe the thing to do is to kind of, have a Georaster that's a bit impoverished. I mean, maybe, for example, it doesn't know about units and stuff like that. But that's sort of whenever images start to be able to handle units, then Georaster will kind of inherit that.
That sounds sensible.
As opposed to, I mean, because otherwise implementing, image operations, for Georaster, where Georaster can have units, is going to be the same exact work, but done in a more bootleg fashion than if images just supported units themselves.
Right. So Shadi, I mean, that to me, I would assume that those are specified by options. Things like units in images will be specified by options.
Yep.
So we should probably design that. So that's kind of the next thing. So Georaster without images, without units and things, leveraging images, but the only additional services that Georaster would have is geo positioning, so to speak, which it has to
Geo
have.
projection and
Yes,
maybe
projection.
Data range, plot range, whatever it's called.
Yeah,
GeoGrid range.
Yes, those two things. And I mean, clearly images fairly soon would have to start wheeling in data range or whatever it's going to be called.
Mm-hmm.
But Georaster has to have that from the beginning, because otherwise it's useless. Now, I don't quite understand. I mean, if you want to find the area of black pixels or something in a Georaster, how would you do that?
Okay, so I hadn't thought of that use case, but there's an easy way to do it. So I mean, say you've binarized your image and now you've got the black and white pixels. So I think the easiest way to do it is I had a usage of I'll phrase it one way and then there's another way it could work. But basically, Georaster data, you'd be able to give it, geo value is really the other function, which is like image value, and basically, but maybe could be used for other things as well. But basically, the idea would be that you could give it something like a polygon, and it will give you, the value of all the pixels in that polygon, just like what pixel value does. But you could also, like pixel value, give it a mask. So you'd give it this black-white mask, and then you'd request, instead of the pixel values, you'd request the pixel areas, and then you'd maybe total those.
Yes.
I want to mention the fact that geographics is very powerful already in manipulating images. So in a sense, what Georaster is going to be doing may be already implemented in geographics. Geographics can reproject images, can find things. There is even internally a geo-image transformation function. Which
I mean, even in this prototype I'm calling that exact function. Yeah, like
okay.
Yes.
Mm-hmm.
This is doing no heavy lifting.
Okay. All right. So what else do we need to know to move this forward? So I think the other question was what this does in terms of binarize of this and so on. And it sounded to me like there's a certain set of image processing functions that, by the way, are probably the same set that don't have to worry about any conforming of anything, that are kind of unary operations that I'm guessing could work here.
Yeah, like edge detect and binarize. There's some, like I think we talked about this a while ago, that there's some that are kind of weird edge cases, although most of them I can't really imagine where you'd want this. But like, for example, blur, because blur is something that you could easily apply blur to any image and you don't need to know about the georeference or anything like that. But the blur radius, you are getting quote unquote the wrong answer, in the sense that, if I had a geoprojection, if I had a Georaster and I blurred it, and it blurred the North Pole with the same radius that it blurred the equator in some projection where the North Pole has been way inflated, it's quote unquote going to get the wrong answer, and that it didn't apply the radius consistently. I don't know why anyone would care about this, like care about blurring a Georaster anyway. But there's some cases like that where it's kind of like, if the function were being super official and quote unquote correct, it would have to take into account geo stuff. But in practice, it probably doesn't have to. So there are some weird cases like that.
Right. But then, I mean, the basic concept would be initially that there's an up value for various image processing functions that make them work on georasters.
Right. On a random technical level, they probably eventually have to not be up values, because if they are up values, so this is a random note, but like a lot of functions, like for example, multiply, if they fail on images, they return unevaluated. Or maybe multiply is a bad example. Functions like, I think, binarize, even if you can in some cases return unevaluated. But then of course, if you do that with a georaster and you return unevaluated, it's just going to go back to the image implementation, and but that's a random technical detail.
All right. Well, this is looking nice. I mean, so okay, should we move on? Okay, let's talk about our next topic, outliers for plot. So my basic issue is when there is a value that is out of range, you have no indication of that in the displayed plot. I think this is wrong. I think you should have a little, there should be a marker like this that is a little, caret or something up here that's like a I'm off scale kind of plot marker. Does that make any sense?
I mean, it makes sense. I mean, at some level, it's implementing clipping style for list plots. I mean, I don't know how specific this is to list plot versus other viz functions, or
no. I think it's a clipping style story. I mean, look, it is a problem. Okay, if this was
if that was list line plots,
yeah, then it wouldn't be a problem.
Well, it's less of a problem. I think it's still maybe a little bit of a problem.
It's a little bit of a problem. But
you can imagine. I mean, for example, it's a convention. People put little, dash lines and an arrow at the end. Where it goes off.
Right. I mean, like if you say
screen.
clipping style goes to dashed on that list line plot.
Right. That does something pretty nice.
Like this.
Mm-hmm.
That's very nice. That's magnificent, actually. I didn't even know that worked. That's magnificent. So yeah, so I think what I'm asking for then is an analog of this for dots, for pure, discrete marker type things.
Gotcha. And I think so. I watched the recording from when you guys discussed this while I was on break. And you were also saying, sort of in the corners for, completely out of range stuff.
Yes. Yes. I mean, well, I guess there's a question even with graphics. If you have stuff that is just not in the plot range, what do you do?
I think graphics should be totally mechanical and shouldn't do anything clever like this.
Okay.
I mean, if nothing else, maybe something that comes with axes or something, or a frame.
Right. I mean, can you switch this to a frame real quick?
Yeah. By the way, do we have Jeremy here?
Yeah, I'm here. I am. I still don't know how you would apply this to a giant set of points that are clipped.
I mean, maybe one option would be to, this is a little bit different from how the clipping style works with the lines, but you could do something like somehow annotate the whole, side of the frame. Like, I don't know, if you imagine having, a dashed, the right edge is dashed because there's there's points that are being omitted that are off the right edge.
Yeah,
I'm not sure how clear it is what's going on.
I don't think that's a great idea. Okay, so that's what that does.
And so I'm just wondering, sort of, in the case where stuff is outside of that rectangle,
I think it should be a clipping style.
I think being.
Okay, so we know which side it's on. I think it should just be a little grayed, I don't know what, arrowy type thing that just
Where
indicates
would it get placed though? Oh, on
at the top. At the top
Okay.
there. And if it was a negative value, it'd be down at the bottom here.
Do you think maybe it could even be placed? I don't know about the axis case, but maybe if it's a frame, it could maybe even be placed outside of the frame. Or
No,
something?
we don't want anything outside the frame. And look, this one isn't outside the frame. If it was placed in the same place that this is, right here, it will be just fine.
Right. The thing I'm worried about is that when you have lines, you can tell when a dashed line is not a line. But if you have points, pretty much
I'm not
any
suggesting it's a
tiny
point.
little
I'm
tidbit.
He's suggesting a different marker.
I'm suggesting a
I
different
understand,
marker.
but even a different marker, I'm a little worried that it's going to look similar. And we even have stuff. I mean, I'm thinking a little bit like geolistplot, or sorry, geolistplot, which of course has different markers for different things. And I'm a little.
Well, I think it would
scared
have
of
to be an out of range marker, which is grayed down and has a sort of arrowy appearance. That's what I would suggest. So that this, go ahead.
Is this only for plot range automatic when you didn't specify? Like if you specify a plot range, I assume this doesn't happen.
I assume it doesn't happen, but I assume you can ask.
Well, I
it
mean,
to
what do you mean it
happen.
doesn't happen? I mean, like if you take that list line plot and you say plot range goes to 0 to 10, I would sure hope that it still draws the dotted line at the top.
I think this was discussed last time, and last time the last time I agree that makes sense. But last time I think we came to the opposite conclusion, which isn't a great sign.
But what if the X range was to 1,000, right? But you're only showing 1 to 10 and it's going up in a ramp. Are you going to show 900 dots?
Potentially.
That's what worries me.
I mean, I expect what I would expect, Jeremy, is that if you have 900 points off the top that are between whose X values are between 0 and 10, then the top edge is going to be dense with missing things.
Yeah, that's what I would think too.
You know, if you've got 100 things that are, you know, off in the quadrant, you know, kitty corner to, you know, one of those rectangles, that there's one marker representing them all.
So maybe, okay, a basic question. What is the default behavior? Like, do you have to ask for this?
Initially, yes, but we might change that.
Okay, because I think if you have to ask for this, I think it's fine. I think if it happened automatically though, I'd be really worried about having weird gray dots appearing kind of out of nowhere, especially because, like, for example, if you set the plot range explicitly, it's very common, you know, you'll have a bajillion points and you just want to display this little area in the middle.
Fair
Yeah.
point.
Like a finance graph where you've got a time window. It's, you know, you don't always want to see everything or even know about the rest.
Exactly.
Yeah, fair point. Fine, but that's the same thing as clipping style. Well, the default is clipping style is none, right?
Right. So we'll turn it on with clipping style, and you know, we may need some little control for what the marker looks like or something. But
I think so. But the case that we were talking about here, so one case is X is within range, Y is not.
Mm-hmm.
And Y is within range, X is not. Those are both straightforward. Now the case is both X and Y are out of range. That means it's a corner. It's in a corner, right?
Mm-hmm.
And that may look a bit obscure.
Would it be enough to have an indication that not all the data is included and without indication of what it is?
No, I think in this case here, it's very nice to be able to have the little dots at the top. I think the case where it is, you know, a corner case where both X and Y are too large, I could imagine just omitting that case or having some other option to turn it on, because I think it's just going to look weird.
Mm-hmm.
Why not just have a single marker in the corner?
We could do that, but it's going to be, I mean, we can try it. We can try it.
Are you just worried it's going to look like it's representing the corner of the plot as opposed to representing something is missing?
No, I'm saying it's got to be a rotated angle, arrowhead that would be like at 45 degrees there. I just think it's going to look like a little piece of random detritus and nobody's going to know what it is.
Well, I think that
or it's
applies
going
to
to
all
look
of
weird
these.
down in the bottom left corner where, you know, your axes are congregating or something.
Yeah, by the way, it reminds me of the fact that I would, in some cases, yeah, that's kind of a stupid thing to say. I was going to say, you know, showing that this doesn't go to 0 on these axes seems like a thing, because a lot of times in a lot of images, a lot of, you know, things, you'd have a broken, you know,
Mm-hmm.
a dash
So some sort of indicator that the
right. And we don't have that at all, right?
Correct.
We should have at least an option to produce that.
And I think we have some ideas on how to do that these days. So We may
Yeah, we
get there
should look at
sooner
that.
than
We
later.
should look at that. But I think the thing that we are immediately talking about is the out of range clipping style for points. Okay, we've got a clipping style for lines. We've got a clipping style, I would imagine, for surfaces.
Yep.
Let's just have I mean, if I say list plot 3D.
Do plot 3D, it's easier. You know, 1 over, you know, x squared plus y squared or whatever. I don't think you want dashed.
I know.
Eh?
I was just curious what it would do.
It did something. I'm curious what it filled that in with. Because by default, it leaves a hole there. So
I don't know what it did. You can investigate what it did. Okay.
Do we have a 3D analog of dashed? Like I don't even know what that would be.
Well, we
Polka
have
dot.
half
it'd be like
tone.
hedge filling. Except that hatch filling is a
Oh.
2D primitive.
Well, what's
So
the
even though
3D
that looks like a 2D thing that we should be able to.
Yeah, what we should the fact this doesn't work is unfortunate. What's the 3D thing that we call what is that 3D thing called?
Try like stipple shading or something. That's the one that comes to mind most quickly.
Whoa.
Magnificent. What's the one?
I don't know if it's coming through on Zoom, but it looks like it's like a portal to another dimension. I mean, like the stipples aren't moving as you rotate it, right?
That's right. Yes, the stipples are stationary.
Yes, that is how that works.
That's kind of nice. We should have an example of that.
That is I've never tried that before, so.
I think there's something better than stipple shading, though. What is that tune shading?
And tune shading is going to be boring because it's a flat surface.
What's the other kind of shading that is more like cross hatching? Well, that's a texture shading.
Why don't you just do question mark star shading?
Hatch shading.
Oh, you did hatch filling last time.
Right.
Yeah.
It ends up looking about the same or something.
It does. It just looks like it has some options, but it just looks like a piece of a meteorite that's been chopped off with metal grains or something. Okay. But anyway, we should add that to the examples for clipping style and so on.
Mm-hmm.
Kind of a nice case. And also for hatch shading. But be this as it may, I mean, what we're looking for is something where even in the 3D case, if it's points, there should be a way of displaying that point as a little gray arrowheady type thing, I think, by default.
Yeah, that makes sense.
But so do we try to do that for every missing point or clipped point?
Yes.
Some limit? Okay.
I mean, every clipped point that is, you know, like either the X or Y component would be in range. We're not going to draw 1,000 markers for the things that are off.
Right, because they will be in the same
The,
place.
the corner case, yeah. Right.
Right.
Literally
corner
corner case.
Exactly. Yeah.
Okay, so we're going to need two things. We're going to need the markers. We're going to need, sort of markers in every coordinate direction, which we probably can get by just rotating a given marker.
Exactly. I was thinking, we'd specify a marker and it would just rotate it to point whatever direction it needed.
I think so. But then the corner case probably should be separately specified.
Mm-hmm.
All right, so let's get some experiments on this.
Okay.
And there's no other functions that this affects. I mean, like geo list plot, I guess it will be the same thing. There could be a corner marker, or not a corner marker.
I mean, strictly speaking, geo list plot, you could put it anywhere and it's off that way somewhere.
Yes.
I mean,
well,
it potentially comes up with something like discrete plot or something, but But I mean, there's not that many point generators. So,
Yes. Yes.
Yeah, what would you
Okay.
do if it was a projection that's only defined on a part of the Earth and the point is outside that projection?
What does geobearing do in that case? Or geodirection?
You give those
well, I mean, that doesn't
geopositions.
matter because those are on the Earth.
Yeah. This is an edge case of an edge case, though. So I mean, yeah, don't
Yeah, I
worry
understand,
about
but that's what the
this.
geogrid
It's a point
direction.
case. The boundary
Yes.
of the
Right.
Okay, all right. Let's go quickly. Talking of such things, compass point.
So this is something that originally spawned a bit because there was a somewhat popular resource function. Basically, you give it an angle on a compass and it will give you a cardinal direction string. We have the inverse functionality already in some geo functions, which is
what?
So if we expand the two sections down there, we can basically, so geo destination, you can say, I want to go 300 kilometers northwest by north. And it knows that direction corresponds to 326.25 degrees. But we don't have a system function that does any translation between these. So it's basically a feature that allows us to specify a direction with these strings, but it's not thoroughly documented.
Well, you might as well have this as an exposed thing. I don't see any reason not to.
Mm-hmm.
So what would it be called?
Well, would we have both directions, like to compass point, from compass point?
I think
or
so. Just
something?
like we have from, hours, minutes, seconds, right? Degrees,
Yeah,
minutes,
DMS
seconds.
strings.
What is it called?
From DMS, I think.
From DMS is, the heck is that?
That's 5 degrees, 6 minutes, 6 seconds converted
know it
into
is, but
degrees.
Into degrees.
Exactly.
Okay. And so if I say DMS string, okay, I get that. So in other words, cardinal direction string would be the obvious thing. If I say cardinal direction string of 280 or something, or 270, I should get east. Is that right?
East is 90. So this is measured
Oh,
from
sorry.
north.
Yes, right. Sorry, yes.
Are
You should get
there
an
different
E by
formats for
default.
these, by the way? Or,
Yes, so-
or is there one standard way of doing this?
Well, I think we should support both the E and the east.
Right.
And
So one can write east or there, and in the geodestination computation, and it works too. So I think
Is that documented, by the way? Sorry.
Your displacement has many examples. Well, a collection of examples. For example, the winds. There is also the tradition of naming the cardinal directions by names of winds. 0.
What is this? DMS string of NS.
Yes. So the idea there is that one can say, I have a number and I want to
see.
return. Yeah, it's not north, south.
I see. So it's like such and such a DMS string of 280 east west.
Mm-hmm.
Whereas if you said minus 280, then you'd presumably get.
Right.
Yes. Okay, so we've already got very nearby functionality.
Mm-hmm. Okay, can you open the page of geodisplacement? And look at the first
By the
scope
way, that
example.
was just outrageously slow. That look up there.
Actually, not the first. Scroll down, please. Perhaps the last. Sorry. No. Sorry, I've forgotten which one it is.
What
One of
what
those is examples documents the various names.
I think you went past it. There.
Yeah, here.
Yeah, exactly.
Okay, so those things should all be string types, just like with integer name and so on. We have certain named types on output. You should be able to get.
You know, abbreviated or non-abbreviated or
Right.
Right, and you see at the end one of the examples of
Wow.
wind.
Look at this. What happened to my screen there? Something has eaten it.
Well, the
Do
black
you see that through
pixelation.
Zoom? Yeah. Do you see that through Zoom?
Yeah.
yeah, it's a
Yeah.
power saving thing.
What do you mean it's a power saving?
That doesn't want to light up all those pixels.
Okay. By the way, Sandra is commenting that there is a generalized DMS string function in the function repository. Let's take a look at that. 1 second. Why is this not working? Sorry. Oh, where do I have it? Okay. That's not where I wanted. Ah, by Sandra himself. Okay. What does this do? Wow, all kinds of cool stuff here. Well, this is something we need to look at. We can't cover it right now, but okay, I unfortunately need to run off. But okay, let's pick it up next time. And remember, Sandra's interesting function repository entry here. Looks very nice.
Yep,
All right, I should go. Okay, see you guys soon.